Thanks, Dr. Ibrahim. Yeah, so while the screen is allowed to be shared, thank you very much for the kind introduction, Dr. Ibrahim. Right, so, okay, great. So it looks like I'm allowed to share. So let me share my screen. While it's going to come up, I'm going to briefly give you introduction on today's topic. Right, it's quite a mouthful, words for the topic. Right, it's creating digital twins and simulation collaboratively. Right, with using Omniverse AI as a platform for the metaverse. But let me decrypt it and why. Yeah, when I spoke to Dr. Ibrahim, he said, let's discuss some latest topics that will be relevant not only for the researchers themselves, but also for the industry. So metaverse is something key term that we would have heard in the last 1-2 years, being very popular, being used by many leading companies and also small startups who are actually looking at building solutions for metaverse. Now, two leading application that we see moving towards metaverse is one is digital twins and also doing simulations. That's what I wanted to cover, how to build digital twin, how to build simulations as a fundamental to the metaverse that we are trying to develop, right? So these two. And the development of metaverse cannot be done by one person, one company, one country. It's like same as internet, has to be done by everybody. So it has to be collaboratively done. Everybody has to contribute and develop. That's where the collaborative comes in. And the last but not least, Omniverse and AI, right? So NVIDIA actually built a platform. It's called Omniverse platform. It's an open platform you can download and develop using Omniverse. It's a foundation to develop the metaverse, which is everybody is building together, whether they are researchers, whether they are developers, whether they are commercial companies who are building this component. And very important component of this metaverse is AI. We cannot forget that. And AI is transforming, right? I think recently there is a Davos discussion where AI was referred just a couple of days ago, where it's a disruptive technology changing a lot of landscape that we know, right? So putting all that together, today's topic, and before we move on and present, I just put it up. Conference which is coming up, NVIDIA conference, again, is free for you to join. There is a lot of nice topics, latest topics by leading researchers globally, and also companies are presenting. Please join in and listen to this GTC conference. Okay. So with that, don't worry. The slide will be made available. If you're not able to get it, you can work on this later. Now, before I get into the details of today's talk, let me share with you why metaverse is important. As we know, the internet that we're using today, it was not built overnight. We took 30 years to build. I would say trillions of effort, either trillions of dollars being spent, or trillions or even time has been spent by many engineers, many companies to take the journey. I'm sure those who actually studied computer science, computer engineering would have learned about what is TCP/IP protocol, right? Which is one of the protocol which is DARPA, born in DARPA's lab and becomes today's fundamental. But the journey has gone from the birth of internet, web pages, into blockchain technology, as we can see today, AR, VR. Of course, the cloud is so important to make sure that the whole explosion of internet become important to us. And recently in 2021, one of the company actually changed name with a word called Meta, right? So that shows a journey of 30 years where we are today. But is this where are we at a milestone to stop and accept what is it today? I don't think so, right? So if you look at this paper, it's published recently, late last year. If you look at it, so the way that they look at Metaverse is going to have 7 different core layers. Infrastructure is fundamental, right? That means high bandwidth, low latency. For example, 5G, right? It's very, very critical for Metaverse. Human interfacing and how human going to interface on so-called the Metaverse is very, very critical. How are you going to consume the internet? Not the way that we are doing today, which is not so user-friendly. It's a bit mundane. The way that we extract, organize, illustrate the data, and visualize it is not as easy. So they're going to make it much easier for you to use. The next, they also look at other components, for example, decentralization of compute. So not everything's stored in the cloud. Maybe some are at the edge, some are in the network, some are in the fog, right? And so forth is being studied. Spatial computing is very important. And this is the time for creator economy, right? So creator economy is all your creation, your arts, your musics, your drawings, right? And all this, will become important as part of the Metaverse. And a lot of discovery will take place and it will enhance the way that we experience. So NVIDIA already started the journey several years ago. So for example, we're working with Meta. They have built a massive AI research computer, I would say supercomputer, to start with some of the foundational work, right? Okay, next. How people perceive Metaverse today, right? There is an interesting research. If you can go, this is a very long research paper. If you have time to go through and look at it, the link is there. So the question was, they wanted to discover, this is done in Europe. They asked all the technical people, professors, researchers, engineers, how do they perceive, Metaverse will change the world or it will evolve in close to 20 years by 2040, right? The question is, will Metaverse will refine and truly be immersive, well-functioning aspect of daily life for at least 500 million or more people in the world, right? Or will it not? So if you can see the response, it's a split, almost 54, 40, 46. 54% says yes, 46% say no, right? So that shows there is a lot of room people to understand Metaverse while we are building Metaverse. Metaverse is not built yet, right? It's a work in progress. It's like, fixing a plane while you're flying. So we are building the Metaverse now, but at the same time, it's changing its shape and how it is being adopted. Some simple papers that I would like you to go and take a look at it, right? If you have free time, this is already in a publication there. If you look at it, I know many countries in the world looking at a 5G, but 6G has been deployed in some countries, at least experimental stage, and they are looking at 100 gigabits per second to 1 terabits per second peak transmission rate. So this is just a foundation looking at a trend, how the fundamental infrastructure is already changing in terms of the landscape. Next paper, if we have time to look at this paper, is nicely illustrates key component of Metaverse. There is NLP, there is machine vision, which is computer vision AI, right? Blockchain, networking, digital twin, and neural interface. All these are going to be critical in the phase of Metaverse, right? For those who are doing a research work, if you're interested in what are the components of Metaverse, take a look at the paper and look at it. Some of them even implemented a simple so-called, I would call, XR, whether mixed reality, virtual reality, and so forth, and doing an AI algorithm, segmentation, object detection in the Metaverse, in the virtual world, right? This is not a real world. Assuming in a virtual world, people are moving around, you want to do object detection. It's a very interesting paper, futuristic. And they look at many aspects. It's a long paper. I would like to look at it because it's a survey, right? It's part of the journal publication. And there is more papers in the space. I want to go through the details, but take a look at it, read it, and you will have a good glance and understanding what is being targeted in the space of Metaverse. Okay, coming back to NVIDIA, what is the way that we perceive the Metaverse is nothing but then 3D evolution of the internet. Today, internet is very much 2D, text-based, you browse, right? And probably there is some element to audio and video, but this is not immersive. this is not high fidelity, right? And it is very difficult to interact and work with this. So what we already seeing, right? That means as I'm sharing with you, industries are already working with NVIDIA in many forms. For example, there is a virtual world where they are creating a virtual economy by itself, right? Creating components and also assets for digital avatar. Just a couple 2 months ago, I saw there's one of the startup in UK has been funded, a couple of millions pounds to do boutique design of clothes for avatars, right? So they're actually designing digital clothes for avatar. Then you can buy the digital clothes for the avatar that you have, and you can change the clothes as you like, right? And it maybe won't be too costly, maybe a small fraction of money. But imagine you have millions of users are consuming, right? So you buy digital clothes for your digital avatar of yourself. So imagine what's going to happen in the next 5 years, 10 years. I'm not talking about what is widely available today, but it's what is being built, what is started. It is one example. Second is in terms of visualization, right? Using a 2D, you can convert the image into 3D already. There is a lot of applications, but that will going to become an industry, right? That, for example, today you can, during COVID, a lot of people were involved in the property segment. They do virtual tour of the house. Now, how about I can actually create the whole 3D of the house and put it into a website, for rental seekers and home buyers. Imagine, that's just an example, right? It becomes a creative industry by itself. In terms of warehouses, how are they optimizing the workflow? Objects being studied in a digital twin of warehouses for optimization. Simulation using scientific formulas and algorithms for various study. For example, a boiler in terms of understanding a CFD, right? For boiler technology. Telecommunication, manufacturing processor, autonomous vehicle, digital twins, and so forth. So this is where NVIDIA already working with industry and is going to revolutionize every industry, same like what AI has changed and impacted every industry today, right? But in order to achieve this, there is a task that we need to ensure that all of us work in harmony. One example is, so we need to help each other, right? So in order to do that, we have to adopt open standards, same like how internet was built today, right? IETF, W3C, ITUT, everybody has worked together with an open standard to enable this to happen. So open standard is something which is critical. Next is in terms of simulation technology. So we believe the simulation technology to make sure we have a metaverse or digital space providing the real world, whether in terms of physics properties, whether in terms of material properties, in terms of behavior, right? It must be real. So for example, if I take a water and I drop in a water, right? Or what mug with the water or just a water droplet, the water droplet naturally has to go, fall down because of gravity. Gravity cannot be seen. But how does it falls? If it is a small water droplet, if the wind is strong, it may push the water droplet to not move directly, but probably, slightly to the side, right? Or the leaf is falling. So all these are physics properties, the material properties, and the behavior has to be simulated or has to be created in the digital twin. That's what is real is. AI is fundamental in many ways. I'll be sharing a lot of use cases and demos for you to understand. And of course, fundamental for this is the compute capability. And in the last GDC, Jensen has mentioned a lot of content in the metaverse is going to be in terms of graphics. So you don't have CDN, content distributed network. You will have GDN, graphics distribution network, because essentially you're consuming graphics. You are consuming video content, which is in the 3D space, all right? So you need to ensure the network infrastructure is very good. So these are some of the key trends that we observe that already taking shape. Industries are already working with NVIDIA to build the solutions. 3D design of goods, content, and environment, as I shared example, digital twins, industrial and scientific use cases. People are already working on this. Training of perception AI. I'm sure those who are familiar and ChatGPT became very famous in the last couple of months, right? So this is an example of your GPT-3. It is your T5. It is a DALL-E, right, which is for visualization. So this is a perception AI, which is coming in. NVIDIA already working with many leading companies and also leading industry partners and as researchers in the space. Robotics, autonomous vehicle, right? Computer vision type networks, right? And avatars, for example, right? Digital human being, or we call it avatar. Those who watched Avatar movie, you will know. Right? Okay, all these are already taking shape and already being built. So in a nutshell, how NVIDIA helps is we provide the Omniverse platform so that you can build, you can experiment, you can do a POC, you can develop a product, you can deploy this product, and you can commercialize it, right? All the way from the researchers to the engineers to the developers, and can participate using this platform. It's a cloud native, it runs on multiple GPUs, it's an open standard, can be used by cross team members to co-design, co-develop together. And it's able to adopt a lot of workloads, open for many other applications, because as I said, Metaverse cannot be built by a company, right? Or not even a group of companies. It has to be built by everybody's collaboratively. So it gives you that platform and architecture. I won't go into details. I'll let you to go and explore from the Omniverse download that you can do. So let me show you in a simple example and with a demo after this, right? But in terms of design collaboration, this is a very old industry, past 20, 30 years, right? People are actually designing, whether it's a architecture design, building, engineering, component design, like using AutoCAD and so forth, or for construction purposes, or even operational research, right? The designers, the project leaders, the clients actually collaboratively work in order to build. It could be a car, it could be a bicycle, designing a building. All this already working place today, together with the visualization element. So I'm just trying to bring you the concept of 3D from existing use case and scenario. So let's see an example of how collaboratively we can design and develop. Now, this is nothing new. It can be done today, and this become a fundamental for Metaverse. So there is a person A, person B, person C sitting somewhere in a different location. They want to design a building, right? Participative, collaboratively, right? So today, by using Omniverse, you can do this. Watch this demo, right? So if you can see over here, one person is designing the floor, right? The other person is looking at what is the right color to be painted on the wall. And then this person looking at how can I put the bench, how to design the bench. So as each of them working separately for the same environment or same area, the whole thing can be actually visualized simultaneously by everybody in a single window, right? So this is what I call as a collaborative design and development. 3 different locations using the application that they're running, but you can collaboratively design an environment. So this is how Metaverse will be built collaboratively, different people, different applications, different interfaces, different APIs. You want to put together, create a 3D world that can be, can be used or can be visited or can be operated remotely by everybody. So this is just a fundamental example. Let's see what are other industrial use cases. This is another use case, again, in the design industry, which is already taking shape. So for example, COVID actually extrapolated or actually enhanced the way that movie was made. If I were to fly a drone and collect the data and bring it into a studio, and I can combine those collection of images, I can make a movie on top of the virtual data that I collected and virtually I render in a space, for example, in this case. I just want to make sure that the sound comes through. Let me enable the sound option. Let me know if it doesn't come.
Okay.
WPP is the largest marketing services organization on the planet, and because of that, we're also one of the largest production companies in the world. That is a major carbon hotspot for us. We've partnered with NVIDIA to capture locations virtually and bring them to life in studios with Omniverse. Over 10 billion points are turned into a giant mesh in Omniverse. For the first time, we can shoot locations virtually that are as real as the actual places themselves. Omniverse also changes the way we make work. A collaborative platform that means multiple artists at multiple points in the pipeline in multiple parts of the world can collaborate on a single scene. Real-time CGI in sustainable studios, collaboration with Omniverse is the future of film at WPP.
Yeah, that's just one example of industry, which is film or making short video clips, advertisement, and so forth. Next, let's look at in terms of manufacturing, right? Could be industrial designers, design directors, R&D engineers, all right? So they want to collaboratively work design. It could be bicycle, it could be a car, it could be any components. And today, a lot of these application, CAD/CAM-like applications, Autodesk, and so forth, all right, already exist. Right? They already have the materials. They already have the digital assets that they can use in order to bring it up and work together. So what happens is all these companies are working with NVIDIA to make sure collaboratively different group of people from different locations, different countries can put together a flow, a workflow, a pipeline. I'll come back to you why this is important, right? I'm just giving you the fundamentals first. So they have a concept, they do the research analysis, they actually work together from the marketing guys to the distribution guys, to the manufacturing guys, all the way even rolling out a product. All this can be done collaboratively as an end-to-end 3D workflow, right? So this is being done today by companies to make sure their work item or their work activities are being productive for them, increase the output ROI for them, right? But this is a fundamental, and this is what I call a 3D internet being built in silos for now, right? Silos for now. Okay, so now the same collaborative 3D workflows can be then brought in. It's a full fidelity visualization and open to everybody through the internet, so that everybody can interact and can visualize, can understand, and also consume that. So for example, there already effort to have, you don't need to go to showroom to buy your car, right? Some of the car makers are doing it. You go to the online, if you're using an Oculus type of device, you can actually immersively see, feel the car, and then you select your color, you select the leather, seat, and so forth, and then you make your car, right? I mean, quote unquote, you build your car that you want, virtually you make, and then you submit for order. So that is an example of how not only the designers and also the engineers are participating to build the car, but they're going to bring it up to consumer world to consume. Now, those fundamental features and components, as I shared with you, already exist today. It's already being used, right? So that means the metaverse already exists. We just need to bring that together into a meaningful way. That's what's being done, whether in the case of connecting the products of design pipeline. For example, in this case, this chain of a bicycle, right? It's all a small digital assets you put together. So people are already doing this today. Now let's look at a digital twin. As I shared, two examples of workloads, two examples of application in a metaverse world. It's a digital twin and also simulations. Let me give you examples of digital twins, right? Okay, this is one example that even NVIDIA, together with our partners, we have done. How can you not only design virtually your data center, but then use that in order to check whether your design and build has done per the specification. You can use it for checking. And after it has been operationalized, you can use the same digital twin to look at all the sensors and data so that you can actually understand and visualize, all right? Watch this video.
NVIDIA Omniverse can be used to build digital twins of high-performance data centers to help optimize every step of planning, building, and operating complex supercomputing facilities. In constructing NVIDIA's latest AI supercomputer, engineering CAD datasets from tools like SketchUp, PTC Creo, and Autodesk Revit are aggregated so designers and engineers view and iterate on the full-fidelity USD-based model together. With Patch Manager connected to Omniverse, the complex topology of port-to-port connections rack and node layout, and cabling can be integrated directly into the live model. Next, CFD engineers use Cadence Six Sigma DCX to simulate thermal designs. Engineers can leverage AI surrogates trained with NVIDIA Modulus for real-time what-if analysis. And with NVIDIA Air, a network simulation platform connected to Omniverse, the exact network topology, including protocols, monitoring, and automation, can be simulated and pre-validated. Once construction is complete, the physical data center can be connected to the digital twin via IoT sensors, enabling real-time monitoring of operations. With the perfectly synchronized digital twin, the engineers can not only simulate common dangers, such as power peaking or cooling system failures, but also validate software and component upgrades for CI/CD before deploying to the physical data center. With digital twins and Omniverse, data center designers, builders, and operators can streamline facility design, accelerate time to build and deployment, and optimize ongoing operations and efficiency.
So this is one example of industrial use case, how a digital twin, built based on all the components that I shared with you, right? The Autodesk or Maya or whatever components they are, you can use it before building to be reviewed while it's being constructed. You can actually use it even to do benchmarking, making sure compliance takes place. One of the companies doing it, for example, in Jurong East in Singapore, to ensure that every vendors are actually working per the specification as the project progresses, right? So next example, NVIDIA is working with the BMW. So BMW has worldwide, thousands in thousands manufacturing sites, and each of these manufacturing sites could be could be assembly, some could be real manufacturing. Some have a different type of activities, and this factory floor need to be repurposed as soon as the new model being introduced. The workflow has changed, the component that is being used will be changed, so they want to be very agile. So almost 30% of the have actually spent a lot of time designing and making sure the flow is correct for every new model being brought in without any glitch as they start the production. So they want to save money and resources for this planning so that they can collaboratively work from engineers from different sites, looking at how the production flow will look like and how to optimize the whole manufacturing flow digitally first in the digital twin. So they build this, and NVIDIA is working with them, right? If you can say every workspace and work area, of course, there is a lot of robots working in place, right? So today, by using Omniverse, they can actually build this kind of a digital twin environment, easily from digital assets that we provide, or it's open. Omniverse is open. You can build your own digital asset. You can put it inside. So whatever you are watching is not a recorded movie. It is a digital twin created, right? Every object, every movement, rotation, the precision, all these can be designed, can be developed, and then you can actually incorporate it as a workflow, and then you can render so that you can better understand and also better plan your activities. All right. So this is an example, but with the BMW, right? So as complex as the engine has many parts, how do you ensure all the parts are going in, assembled together by the factory floor as it goes in, especially when they start the new manufacturing of a new product. So this is very important to design and verify. This is with the AWS, which you're working with in terms of warehouse optimization. So this is physical, real, where they have robots. Yellow. This is a blue color is virtual. You can see the Omniverse digital twin looks almost as real as it is, right? So the intent is, they have huge warehouse spaces. This can't be operated by human being, as you know, all done by AMR, automatic mobile robots, which moves around. How do you design the space? How do you position how it should be as the warehouse, keep changing, and they want to keep the automation at the highest level. So some of the components are, anyway, it is built by using existing tools like Autodesk, as I've been sharing earlier. And the whole workflow, it is to create this digital twin to bring operational efficiency for them, right? Okay, there is more can be done, including, for example, NVIDIA has a stack called Isaac Sim. Even the operation of the robot in the space can be tracked. We call it as a sensor. The sensor inside the digital twin is actually an entity, and that entity will emit a lot of parameters and informations. And that parameter and information in the twin world itself can be used, can be captured, can be analyzed so that you can do a different type of tweaking. So if you can see over here, this is the digital twin, and this is the real, looks almost the same. So by changing the design workflow, right? Changing some kind of work items. So for example, if you have an arm with a sucker to suck and pull, pick and place kind of object, what happens, there's a different boxes coming in, different sizes comes in. How do you actually change the sucker's capability so that it's not too hard, it's not too soft? Too soft, the box will drop. Too hard, it may damage the product, right? How you get that trained in a digital twin before it's get deployed into robot.
In Omniverse, Ericsson builds city-scale models.
So this is another example how we are working with Ericsson, Omniverse, all the components that I shared with you, bringing value to industry. This is where the ray visualization, 5G signals actually being visualized, understood. How does it reflect building to building? Does it allow penetration? If it's not no penetration, then it has a less impact of reachability of a device between the tower and the mobile device. So they want to visualize in a real, in real world type of environment with the vegetation, with the buildings and so forth. Is another example of industrial
accurate down to the materials of the buildings, vegetation, and foliage. Then, wireless network components are added, including the precise location, height, and antenna pattern of each transmitter. Ericsson built a custom Omniverse extension, enabling them to integrate radio propagation data and leverage Omniverse's RTX accelerated ray tracing to quickly visualize and calculate the quality of the signal at every point in the city. Because Omniverse materials are physically accurate, the intensity of reflections are precisely determined. Antenna beamforming and signal paths can be accurately simulated and visualized. In the simulations, the lobes signify transmitter antenna beamforming and the straight lines are signal paths. The colors of the signal paths denote strength in decibels and data throughput, from blue is the weakest to red is the strongest. Visualization is a critical capability for Ericsson. With Omniverse VR, network engineers can virtually explore any part of the model, teleporting to any location, anywhere in the world, at 1-to-1 scale. As they tune the network for optimal performance or identify path disruptions, they can literally see the effects of their adjustments in real time, things which aren't visible in real life. In Omniverse, Ericsson can perform true-to-reality remote simulation of entire 5G networks, enabling them to design more efficient and reliable networks, conduct remote field trials, and speed up deployments.
So another industrial use case I want to share with you, right? In this case, is an avatar as a digital human. So we see digital human is going to be a very important element in Metaverse. So the digital human has to be, able to do conversation. It has to have a context on the conversation, aware throughout the conversation between one digital human to another digital human, or digital human to a human, for example. It is able to plan and do some actions. Gestures are very important. Emotions are important. Body animations, vision, speech contacts, face animation, and so forth. So this is another key research work being undertaken. And a lot of companies are already building today the components of digital avatar, even bringing services to the end customers as we speak. Let's see an example of how NVIDIA has illustrated in our own lab that we have developed while we are working with industries.
Let me welcome back Toy Jensen, an application we built with Omniverse Avatar. Remember, Toy Jensen is not recorded. He's completely real-time, making eye contact, making conversation, and fully animated. Hey, TJ. I got a few questions for you.
Sure, ask me anything.
What is synthetic biology? Synthetic biology is about designing biological systems at multiple levels, from individual molecules up to whole cells and even multicellular assemblies like tissues and organs to perform specific functions. It is also known as symbio, which stands for synthetic life. Can you give me some examples? Some current uses of synthetic biology involve creating biofuels.
Sure. Just in interest of time, I can play the whole video, right? But you understand the concept, which I'm trying to say, the gesture, the response, knowing the context. As we are using Chat GPT, for example, right? It's one which I call the conversation part, for example, using GPT-3, right? NVIDIA has a Nemo Megatron. So we provide a large language model as one of the services where you can train and localize it for your own use case. You can train for Bahasa Melayu, for example, right? And the whole, the Toy Jensen can speak to you in Bahasa Melayu in the local context, understanding the local scenarios and local use cases. So the intent is to build avatars which is able to, in a real time, aware of the context of discussion and have all this capability, not only the language model, but the rendering component, bringing the full fidelity in terms of emotion, whole body, hand movement, and so forth. All these are important. Now, how are we building all this? Right? How NVIDIA is developing? Nothing is built overnight. It is not a magic. So a lot of engineering work goes in, and quite a number of work that we publish in papers. So, for example, this is a neural graphics, or we call it as NERF, N-E-R-F. It actually is a build based on some of the MLP, right? Multi-layer perceptron-based components. I won't go into details, but take a look at this, how AI plays a critical role. So come back into 5 keywords. I talked about digital twin. I talked about simulations. I'll cover simulation after this. I talked about how collaboratively we're going to work, use Omniverse as a platform, and AI is a fundamental component. Look at this paper, how a 2D image can be converted into 3D, right? So again, not single company, not single researcher can build this. All of us has to work together, and this takes a time and effort to put this together. So this NERF, actually NERF available in the GitHub. You can take it and download, you can play with. So in this case, a 2D photograph, you convert into a 3D scene. Right? So just taking a few of the photos of the person, I can take a 3D view. So in this paper, if you go through how the missing voxels are reconstructed using AI so that you see the person in a 3D. Right? So you may have only few photos or few, it's like a photogeometry type of concept, right? So you have some photos, but not all photos for the missing angle reconstructed using AI so that you get a 3D object. Why is it important? In the metaverse, you can't be creating every object by drawing. We have to automate the whole process. This is an example how you can create a 3D object, right? Another paper is called Get 3D. It's a paper has been published as well. The source, the code has been shared. Take a look at it. And another example of how we are trying to help from 2D to get into 3D, right? So you take a 2D object, you go through the AI, have the depth understanding, there's a color information comes in, you can create many objects, okay? So now, this is another example. The same concept is being used in order to apply an autonomous vehicle for a drive sim, right? The object is being extracted, put it in, so that we can render for a specific use case and scenario, right?
Supercharging DriveSim with a neural reconstruction engine to enhance simulation with AI and data captured by the fleet. In a matter of minutes, the neural reconstruction engine can reconstruct a full 3D digital twin of a recorded drive from sensor data. Objects are harvested and reconstructed using AI. Large-scale asset and scene libraries are created from real-world drives. The reconstructed scenes and assets are loaded into Omniverse and are ready to use in DriveSim. Using NVIDIA Drive Map, we can place dynamic objects, such as vehicles, as well as pedestrians. Recorded data can now be turned into fully reactive and modifiable simulation environments for closed-loop testing. New scenarios can be authored using synthetic and harvested scenes and assets.
Don't worry, I'll send the slides, go and take a look at the video. So it actually, now you can get a concept by taking the digital 2D assets, bringing it together, making it into object. You can author your scene, render it, create the digital twin of it, and then you can work within the digital twin to use it for different type of purposes, including training a neural network for autonomous vehicle. Now, this is what I call is building the metaverse in silos for a specific use cases and scenarios. And we put together all this, that will create a metaverse, right? So I can go to this particular street. I'm not sure where exactly this is. I think it's part of Santa Clara Street. I can, if I have a Google, for example, if I have Oculus or any head-mounted device, I can virtually go and see it, right? Assuming all cars has a camera, the camera is actually capturing images, and these images are sent to the cloud, converted into a 3D. From 2D to 3D, I can visualize the place in a real time, right? All this is being done as we speak in silos, but is being put together, right, for different kind of use cases. Okay. This is another use case together with the Bentley, who's using it for visualization of a construction site, right? Okay. So I won't go into detail. You take a look at this. There's a link is there. You can watch it in the YouTube, right? So how are we building this? Going back to the fundamentals, it's engineering work. A lot of work being done on this particular space, right? Modulus is the SDK. You can download for free. You can actually develop some of the physics component for simulation, right? I'll go into how engineers and ISVs are working together with a specific workflow. It could be CFD, it could be thermal visualization, it could be electromagnet components that you want to visualize, or like in the case of Ericsson, or acoustics, sound, or multi-physics, combining multiple components of this, all right? Now, you can actually take Modulus, which has a package of quite a number of libraries there, or you can even include your own implementation of your library. Some of the algorithms, written in a CUDA, you can put it in, and you can create a full physics data-driven pipeline to create a scene, so that you can actually visualize some of the physics properties themselves. Okay, so this is a simple, the flow is very simple. You can actually have, using the Omniverse component, that whichever you have trained, right, where you can actually do the inference, the output, you want to visualize it, and then the rendering will take place in Omniverse. And you can combine multiple pipelines to do a scene creation. So, like in this case, we are working with Siemens. Siemens are looking at it in terms of the a boiler entity, right? Where they want to understand corrosion at boiler before a corrosion takes place.
This massive heat recovery steam generator uses hot gas exhaust to convert water in the pipes into steam for the turbines. Predicting corrosion to avoid downtime is challenging. Reduced order models aren't extremely accurate, and full simulation takes expertise and time. Siemens Energy is developing a digital twin with NVIDIA Modulus for the multi-phase turbulent flow. With point cloud data to train a physics-based AI model, they can infer high-fidelity flow shown by the streamlines in seconds. This could reduce downtime by 70%, saving the industry $1.7 billion a year.
Yeah, that's another example of simulation that you can do, right? This is a quick example how
Total worldwide wind energy capacity currently exceeds 750 gigawatts and is growing faster than ever, with an additional 650 gigawatts to be added in the next 5 years. For companies like Siemens Gamesa Renewable Energy, optimizing the configuration of each new wind farm is critical for getting the most out of their investment and reducing costs for consumers. When designing a wind farm, it's critical to place each turbine so as to minimize the effects the turbines have on each other due to the wake that they create. Accurately modeling the wake requires high-resolution, high-fidelity simulation data that is specific to that wind farm, such as the geographic location and the terrain. The gold standard for generating this data is the large eddy simulation shown here. But to run just one iteration for a single turbine can take 40 days on a 100-core CPU. And with so many iterations needed to develop an accurate model for a specific site, using CPUs is impractical. Using NVIDIA Modulus and NVIDIA Omniverse, Siemens Gamesa has been able to reduce that 40 days to just 15 minutes, approximately 4,000 times faster. This is accomplished by running the model at a lower resolution, and then, with a PhysicsML model trained using Modulus, to enhance or super resolve the data. And the results are functionally equivalent to having run the model at full resolution. Let's take a look at the same data presented in a way that clearly highlights the coarseness of the low-resolution simulation. Here, they look like pixelated blobs. In the super resolved flow field, you can see the finer vortex structures. Now that we have the simulation data, we can build an accurate weight model for the site and optimize the placement of each turbine. Thousands of iterations, accelerated by NVIDIA GPUs, are run as part of the optimization to achieve the maximum power output for each farm while minimizing the cost. And the impact is huge. When using NVIDIA Modulus and Omniverse for a typical 1,000 megawatt offshore wind farm, optimization can provide power to supply up to 20,000 additional homes, and to do it at 10% lower cost.
That's another example how digital twin takes place, right? In terms of simulation. This is where we have seen the simulation being used with the digital twin concept, right? With all the sensory that this comes in the robotic space. So you can watch the video later. I'll share the link, right? So you can see the physics properties, components that you build, you put together becomes a fundamental as we build the metaverse. All that is important in the 3D internet is the metaverse, right? That's what I shared with you. And you can do it on your own for your own scenario use cases. Download Omniverse, download Modulus, and put that together, play around. And also, you may have your own AI models that you have developed to ensure the correctness of the visualization based on certain AI algorithm that you are developing, right? Or you're working together with the partners. Take a look at it, right? Okay, next is another example.
Dear fellow scholars, this is 2-Minute Papers with Dr. Károly Zsolnai Fehér. Welcome to episode 600. And today you will see your own drawings come to life as...
So this is interesting I wanted to share with you in terms of generative AI. So the word called Gen AI became very popular, but it's not only by GPT-3 for text, but also for visualization. I call it anything to anything Gen AI. Give a text, it gives you a picture. Give a picture, it can give you a text. It gives you audio, it gives you a text. It gives you a text, it can give you audio, right? It's anything to anything. That's how there's a lot of work being done in the Gen AI space. So this work that you have done using a GAN, those you're familiar with the AI
beautiful
GAN network,
photorealistic images. And it turns out you can try it too. I'll tell you about it in a moment. This technique is called GAN 2, and yes, this is really happening. In goes a rough drawing and out comes an image of this quality. That is incredible. But here, there is something that is even more incredible. What is it? Well, drawing is an iterative process. But once we are committed to an idea, we need to refine it over and over, which takes quite a bit of time. And let's be honest here, sometimes things come out differently than we may have imagined. But this is different. Here, you can change things as quickly as you can think of the change. You can even request a bunch of...
Okay, I want to go into detail. I'll let you go and explore, right? So this is a DALL-E, for example. This is the GAN, Generative Adversarial Networks, which is part of the Gen AI, evolution of it. It's all exploding. All these are fundamental components, which is important for Metaverse. So coming back, so NVIDIA's intent is to give a platform, open platform, that is free for you to download and develop as an engineer and researcher. Of course, when you go and go to the enterprise scale, you want to deploy and so forth. There could be some licensing for the platform. But today, you can download and then you can use it. If you can see the layered approach, AI is one of the layers. The simulation another layer, rendering another layer. All these layers are already exist. It's nothing new. We already have it. But we are bringing it together, making it into a platform, which is called Omniverse, as a component for Connect, Nucleus, Kit, simulations, and RTX rendering to enable the whole pipeline that you are developing, right? And then you can develop it in the cloud as an app, as a microservice, and all this is possible because the whole framework, the whole pipeline actually made possible by the components of Omniverse. Right? Okay, so this is the details of the components, download, play with, and you will have a better understanding. So in order to share, is this an open standard? We work with the community. So USD, Universal Scene Descriptor, is important for the rendering component. But not only that, we are working with many other players, right? So but there's many standards, MDL, USD, and so forth. There's just a few that I've stated here, but there are more as we speak. The standards being adopted for all kind of operators as we build the Metaverse, whether format of a file, the input, the application able to plug in and talk to each other and so on seamlessly to exchange metadata and features across this pipeline so that it becomes a cohesive and coherent application, right? All this being done as we speak. Now, just to, before I conclude and pass over to Dr. Ibrahim on the Q&A section, creativity is the key. Imagination is the key. How to use this, right? While NVIDIA not intend to develop any end application, right? So we don't provide an application. Of course, we have the fastest GPU and the best GPU in the world, like Hopper 100 and L4, which is the best rendering GPUs available. We provide all the libraries and the middleware and the SDKs and platform like this. And many of the researchers and the developers and companies are taking it to develop the end product and solution by themselves. So this is one example in the case of one startup actually developed a scheme to create and train the model for a video analytics application, like what Dr. Ibrahim shared earlier, right? To go and count the number of cows. So today he has to work with his partner to fly the drone in Australia. So visually go and collect the data and come back, right? But the cow positioning and the landscape of the area can change from one area to another area, right? There could be a shadow, there could be a cloud, there could be trees, everything blocking. I remember when we were working in 2018 and 2019, the trees were blocking. So we couldn't really see whether is it a cow or is it something else behind the tree, right? So you have to build the model to predict. What happens if I can create the scene in a split of second using Omniverse into digital scenario and then run a model to do object detection? It's what we call synthetic data generation in NVIDIA. So they have used synthetic data generation in their case where they want to train the model for license plate recognition. Let's see this example. Right. So in this case, if you see, this is a this is a, I think at one frame. Okay, this is the real world, right? And you can see the real world in simulation become a digital twin, right? The building looks same, right? But it's not. This is actual, and this is the digital twin. So now I have all the objects of cars. Remember the nerve, the Get 3D, all these models and libraries and framework that we have given, all AI driven. You use it to create a digital car, red color, blue color. You see the physics property in terms of shadow, because of the light, sunlight is here, right? The sun can move in different direction. The shadow will move together. You create a digital twin of the street. So with this digital twin of the street, next. So this, it's a IVA solution providing company. Now they can create, they are creating a synthetic data for a license plate. You can change the numbers, you can change the color. Like for example, in Malaysia, you have so many different type of license plate, right? Automatically, synthetically, you can create Lima, Putrajaya, right? Up, down, Bumblebee, Malaysia, whatever you can create. So then after you create, you load that as an input into the car, as an object embedded to the car, right? And then the car can move in the street, and then you can detect license plate in the digital world, right? So you can train the model without going to the street and then having the recording there using a drone or whatever it is. You can create the whole scenario, synthetic data, and apply. Right? So this is an example of how the building blocks that is being built eventually for Metaverse can create ROI. There is a business efficiency. There's a return of investment. Economically, you can save time and money and improve the model in AI. See you in Omniverse. Download, join the forum. There is a lot of documentation available, tutorials available, and learn and join the developer community. There's a lot of tools, trainings available. As I shared, get the link and work with. And please join our NVIDIA conference for developers. Every year, Jensen's keynote speech last year, for example, had 40 million views, something that you should not miss for those who are in the space of AI, accelerated computing and development. Join. I'll leave the page on. You can just take a mobile and then snapshot and register. So with that, I pass it back to Dr. Ibrahim for Q&A.
Thanks, Dr. Ettikan. I think a very informative talk today. Definitely, it's like what they call Omniverse is a good way for Metaverse for all the developers today. I think some of you are coming from engineering or computer science background. And of course, there are some business entity or business developer coming, joining us today. I think allow me, Dr. Ettikan, to open for, online kind of question first from the floor. If you have anyone, you just open, unmute, and then you just straight away go for questions, if any. Anyone to have? But basically, I prepared a few. From the question feedback, we have a lot of questions anyway, Dr. Ettikan. So I think they ask some of the participants. They are really looking at Omniverse for their autonomous car industry. So I think one of the question is how NVIDIA can support for digital twin for virtual testing of autonomous vehicle. I think this is maybe I pose this question first to you, Dr. Ettikan, if you want to respond first.
It's a good question. Yeah. It's a very important question. So today, NVIDIA already working with many of the AV manufacturers, auto manufacturers, right? Not only AV, but also the current work that they're doing with different type of vehicles, including EV, right? So we have a platform called Drive Sim. So Drive Sim actually runs on top of Omniverse. I'll be able to share the link over here. And we actually using some of the components that I shared with you in the drive sim. Our drive sim has a component to enable the digital world created for the autonomous vehicle to be tested. Right? So as you know, in order to create a model which is fully tested for all possible scenarios in our real world, it's impossible to be done. So our partners who we are working with is they actually record a scene, like I shared with you an example, by using a real car and a video camera, and they bring back the content to the lab, and then they can actually virtually create different type of scenes, different combination of scenes and scenarios, like some constrained scenarios like I shared in the demo, right? So then after that has been created artificially, in the digital twin space, then next they test their algorithm, whether object detection, segmentation, speed detection, or the distance detection, or a bounding box for the vehicle to understand the space between the vehicle A and vehicle B. All these AI models that actual AV car is running tested in the digital twin in the AV space. I'll share a link. I put a link here for the drive sim. We call it as a drive sim. SDK similar like this.
You're putting on the chat, right? Okay.
Yeah, I'll put it. I'm just looking for the link. Go ahead. Next question.
Okay. Other than that, I think we have a lot of questions, but quick one. I think one of the question is, as we see, okay, the question is how basically the Omniverse validate the real physical world as compared to the simulated one before the model can be used?
Yeah, sure. So it's a very good question. I will try my best to answer, right? Because the question is validating a model, right?
Yeah.
So one is the, I would say, how the model being created. Is the model being created using AI, or is the model is created using some tools in a specific authored, a specific scene, right? So if it is using, for example, modulus physics properties, so it is up to the developers who's actually designing and implementing the physics formulas, right? And the physics formulas in the modulars are written using, you can use, you can use CUDA native language to write and develop, or you can use some of the plugins from different third-party application to be imported into modulars to run. So then the accuracy of the model that we created based on the model written. So the author of the model need to validate and verify the model by themselves, right? Because this depends on scenario to scenario, situation, and components to component.
So that's how it's validated, right? I think, especially for physics properties. How about for the AI? I think just now you.
So for AI, AI, in terms like, for example, you want to develop, a object, a 3D object, like a photogeometry example, like a nerve, right? Again, in that case, using a multi-layer perceptron, and then building, you have voxels. So as a voxels evolve for the object in a different angle, how AI model actually used to fill the potential pixel will look like by predicting the next pixel given your previous pixel, right? So you got to go back as like a normal AI model that you develop. Yeah, image processing. AI model is being developed. Then you test and validate the model for the AI model that you develop or network that you're using.
Okay, I think if you allow to expand this question, it is quite interesting because towards the end, whatever we're trying to do, for instance, let's say we talk about just now on the Ericssons, right? The Ettikan. If you look on the Ericsson, we can see of the power beam from the antennas and everything. Just to get an idea from you, for instance, we can have our network analyzer to confirm that the beam is on that directions. So maybe it is something like what we can see towards the end, those going to validate our 3D or our modeling. Let's say if we talk about the Omniverse, the 3D world that we have created. So all the properties just now, towards the end, at the end, human or the expert need to validate. So how you see this issue when we are talking about the innermost of data, right? Big data. So how people can really quantify it and validate it in the perspective of the data is too big, especially to confirm. Let's say if people, the engineer on the field, right? What they're trying to do, they bring all the measurement device, for instance. So maybe you have some ideas on this one, Ettikan?
Yeah, sure. So if I understand the question correctly,
yeah,
you know, in the 3D world, that is, or in the metaverse, there's a lot of digital assets going to be there, digital entities, digital components, right? And how do I validate and ensure that digital assets and entities could be authenticated, could be validated, and so forth, right? So, I mean, the area is still very much at a very early stage, right? People are still working on it, and they're working on many ways doing it. So one of the approach that people are taking is, for example, to ensure authenticity. That's what you claim, using blockchain technology, right? So that's one way to authenticate, to check whether the origin is valid, as what you claim is okay or not, by using blockchain as an infrastructure. I'm not saying that blockchain is going to solve the problem, but it's infrastructure to ensure that it's authentic, it's valid, it's trustworthy, and you know the details of it. But I would say currently there is a lot of work, activities taking place as a community to look at this as well, right? So how do I know the digital entities original properties by using, for example, I want to look at materials, right? Yeah. So if it is compliant and written by MDL, material definition language, then I look at the properties, parameters, and component through MDL, and then I can authenticate on my end by using MDL. And so I would say this is the way that at least I observe quite a number of companies are using open standard. And using the open standard, you can actually come up with the methods and models to do the validation or authentication and so forth. But it's an area which is evolving fast.
Yeah. Thanks, Ettikan. I think we have maybe I limit for. I have few other questions, but I think this is more relevant. I think one of the question here is amendment of law necessary to regulate the metaverse. From your point of view, Dr. Ettikan, relating to the regulations.
Yeah, I'm not a legal expert.
Okay, but yeah.
So I'm not able to answer the question. I think it is still early, but of course, any ethical concept must be evaluated and must be ensured it's all complied to the governance and ethical values and so forth. I kind of agree, but I don't know how, who, and when, and what to be done. But as an engineer, as a researcher, as a developer myself, innovation is very important, and I think we are at the early stage of innovating, bringing the concepts together, validating, testing. That's my opinion.
Yeah. Okay. Thanks, Dr. Ettikan. I think they have another questions. Basically, there are few students, I think here as well. So they are interested. Maybe you can. I think the question: what I need to be prepared for my future job in this Omniverse related kind of technology. You may advise on this one.
So it's a famous question that you always get, right? In fact, I was just talking to somebody a couple of weeks ago, right? At one of the university. They are looking at creating a course called Metaverse for engineers. Or I can't remember, engineers in Metaverse or something kind of name that they are created, right? So, I mean, it's quite interesting. At the same time, NVIDIA actually creating a content for one semester content, which is more for graphics and an Omniverse, which we are putting it together, right? So where there is AI element to that, there is a design, graphics design component to it, multiple content for lecturers in the university to consider as a one semester subject to teach the fundamentals of Omniverse, or engineering component, or programming component, or algorithms or components, the rest is, which is fundamental for Metaverse. We are putting that syllabus together. Currently, it's early access. Early access means you can go to the NVIDIA website, which is for educators, and also to the lecturers. You can download. You have to submit a request. I think you can, once they approve, you can have a first draft of a content, one semester subject. So coming back to the original question, how to get yourself prepared?
Yeah.
I think fundamental is just be curious, right? And try to join. There is a lot of webinars that we provide from NVIDIA, and join the webinars. Join GTC is very important. It happens twice a year. Most important developer conference on the earth for me. Those who are looking at AI. And keep reading some of the good papers being published in that particular space. Yeah, I mean, this is very early. So I guess being curious, joining conferences, if you can, whether virtual, download like Omni, try to play around with it. A lot of reference codes are given. Do a final year project if you're in a final year student. If you're a second year, you want to do your a small project in your computer science papers, try to do something along with it, and start with somewhere. It's a long way to go, because those who are in school today, this is where the world that you will be in. I'm probably the user of the world in the next 10 years.
Okay, thanks for your kind advice. I think allow me for last question. This is I think from guy from energy industry. I'm coming from energy industry. How I can start to understand Omniverse and use for my works, for my jobs?
Yeah, sure. So energy industry is a very important industry for us.
Yeah,
people
assuming he has no background all of this stuff just now you mentioned. So what they should start?
How to start, right?
How to start, yeah.
Yeah, sure. I think the most important is, I think first step is try to join some webinars and some introductory content first to understand what are the features and components like I shared with you. That's the first step. Second step is, important is, what is your business case, right? What are you trying to solve in the energy space and industry, right? Like for example, Siemens looking at wind farm. So they want to understand how to position the wind farm in a right location in the sea test bed, right? One cluster. So the positioning of it has to be based on data. So if they actually collected data, in the different type of, different sea bed, it can be even in the ground itself, right? So they collect, there are many entities providing data they've collected over a period of time, including the wind strength, wind blow, wind direction, and so forth. So if your problem statement is positioning the wind tower, windmill kind of structure that you're building in wherever, so that is the definition. The right place to position at the right angle so that I can get maximum energy throughout the year. That's my problem statement. So if you can form a problem statement in your space, it could be CFD. It could be in terms of, for example, in oil and gas space, right? You have enormous amount of seismic data set that you're collected. So you want to visualize and understand properties of the data rather than being X-ray kind, imaging. You want to have more features to it, right? So you can use Omniverse to visualize and render the image and content for an oil well, for example, or you can even be operational efficiency. So define a problem statement. Step number 2, know the basic building blocks, define a problem statement, and then look at some of the demos and some of the pre-work done by companies or research labs or different entities, so that your problem statement then mapped into the references people have done. Then you can put up a small project to do a proof of concept first. Right? That I would say 3-step approach. Understand what it is, Omniverse, what is Metaverse, join our conferences, webinars, and so forth. You have a basic idea. Then do a problem statement. Define a problem statement for your own use case, for your own industry, for your own job. Right? After you define the problem statement, then talk to industry, talk to partners, talk to people, and see what can they do. Right? Evaluate, is the problem statement and then what industry can do is too big the gap, or is it possible to be done? If you think it's possible, then propose a proof of concept. So do a POC first, or MVP, before you get into actual project.
So hopefully answer the question from our participant today, asking from energy industry, the Ettikan. I think it's about 4 p.m. now. Again, it is very informative talk. I believe it's not only for newcomers, but of course for those who are, the keyword just now, have a lot of curiosity to know more about Omniverse. So it is interesting to have this series of talk. Basically, just a quick one. Is there any DLI session for Omniverse, Dr. Ettikan? So I think we can
good
advise.
question.
Yeah,
There is a DLI session that's available. That actually just go and search Omniverse DLI has been put together. But the current DLI that we are providing, it's a basic components and blocks, not the whole workflow and pipeline. So in the coming GTC in March, there will be end-to-end digital twin type of a DLI will be given. So try the current DLI, which is open, free. There is quite a number of them in the Omniverse. Just search NVIDIA DLI. You will find, experiment it, but there's a very fundamental components and so forth. But the actual one will be released in the coming GDC. Then after that, it will be open.
Okay, thanks. Just last one. I think we have numbers also from lecturers and teachers here, right? I mean the lectures, the professors here. I think very interesting. You mentioned just now about early access for 1 semester. So can you share any more information about this one on the link if you have it?
Sure.
Maybe you can post later.
I will just check quickly.
So it's open for any university, right? So they can pick up this one as part of their syllabus, I believe, right?
Yes, exactly. So that's the intent. So like, for example, we have a syllabus for DLI, right? I think, Dr. Ibrahim, you are teaching this at your place using the DLI content, right? So looking at the DLI content, similar like that. So let me just share with you the content.
So then we can plan. I think the lecturers and the professors can plan to have this during their short semester, for instance. This is a very good opportunity.
I'm sharing the screen. I'm not sure whether it's coming. Give me one.
I think we're allowed to share. I think. Okay, now it's okay.
I'm allowed to share. Okay.
Okay. Yeah.
Can you guys see this?
Yes, we can see it. Teaching kids.
See, right? Teaching kid, right? So I'm not able to. Give me 1 second. The screen is blocked. Okay. So over here, if you can see, if you browse, go down at the bottom there, this is the teaching kit for graphics and Omniverse, right? So it's early access. Apply here, then you will get the whole content that how you can use it to teach in your class.
All right, I think that's very interesting. I think we can even I think those who want to upscale from the, because we also have the software developer that joining our session today from the list. So I think this is where they can start with from their angle to get better understanding on Omniverse, and definitely inside they have a lot of component inside. I think again, Dr. Ettikan, I think it is we have a very good session, very informative talk today. Hopefully this is opening to everyone that looking the gateway from Metaverse from Omniverse perspective. I would say, I think again, thank you, Dr. Ettikan, for your time, and also thank you to all the audience for joining us today. So hopefully we can have a series of sessions with other university as well in future. All right. So yeah.
So I think I mean, from my end, I would like to thank yourself, Dr. Ibrahim, and also CAIRO for organizing the talk together with Novorian Jacob, who kind of helped to set up this. And I think Novorian Jacob is planning to do this as a series probably every 2 months once, right? So we had one 2 months ago. This is the next session that we have.
Yeah.
It would be good that if the audience were joined today, if you can fill up the form and then tell us what is your area of interest. Of course, you can give a feedback about this talk and how we can improve this further. And for the interest of the organizer, which is Novorian Jacob, and also with CAIRO as well, if you can tell us your future topic of interest, where do you think, small interest, then we will share those topics in future talks. So this we call NVIDIA Tech Talk series, which we are doing in this region for many countries, right? We've been doing this in Thailand, Indonesia, Vietnam, and then so forth. So with the idea of starting, so this is the second talk that we are doing. So look forward to see you in the next talk series. Based on your demand and title that you're looking for, we can get the right person from NVIDIA engineers and researchers to come and share with you. Thank you.
Thank you, Dr. Ettikan. I think with that, yeah, thank you. Thank you, Jacob, for having with us today as well.
Yeah, just a quick one, Doctor, if you don't mind. I just want to reiterate what Dr. Ettikan said. We are planning to do another at least 5 more sessions for this year. So the next one is planned for March. So your feedback form is very important to tell us what topics or areas that you'd like to know more about where NVIDIA AI is concerned. So we'll try our best to accommodate your requests. So look forward to receiving your feedback. Thank you all.
Thank you. Thank you, Jacob. Thank you. All right. I think with that, again, thank you everyone for joining us today. Thank you, Dr. Ettikan, for your time. I think with that, okay, bye-bye everyone. See you for March session, Tech Talk. Thanks, Dr. Ettikan. Bye-bye.
Yeah. Happy Chinese New Year, everybody.
Yeah, happy Chinese New Year. Long break.
Yeah.
Okay.
Thank you.
Bye-bye, everyone.